but I'm younger, so you know.
Who are you? And where am I?
Oh, silly me. You see, I'm the number devil. I came to teach you about mathematical topics. You can't call me by my real name because you're not in the inner circle.
The inner circle?
Never mind that. Anyway, we have to do a lot in this short amount of time, so how about we go somewhere else? What do you think?
Okay.
Oh, probability is such a fun math topic, isn't it? It's actually my favorite, did you know? And rather simple too once you get the hang of it.
Simple? There's nothing simple about probability. What with all the ands and the ors and different combinations, it's way confusing.
Oh, please. Come on, it's easy. I'll show you. Now pick a card, but don't look at it.
Okay.
Now how many cards are in this stack in all?
52.
Exactly! Exactly. Now let's start with colors. How many black cards are there?
Half the stack is black. Everyone knows that, so 26.
So what's the chance of drawing a black card then?
Well, I don't know.
Well, let's work it out. There's 52 cards in total, right?
Yeah.
So 52 is your denominator because that's the total number of cards you have.
Well, I guess that makes sense.
Well, it should. How many cards did you get below of just black?
26, half the deck.
Correct. Do you see what I'm doing now?
Yeah, because 26 is the numerator, because that's the total number of black cards I have, and 52 is the denominator, because that's the total number of cards I have. So that means I've got a 52nd chance of picking a black card?
Exactly. Now can you reduce that fraction down?
1/2. So there's a half a chance or 50% chance that the card I picked is black.
Right you are. Now how about you turn that card over and see if you're right?
Hey, it is black.
Good job, man! Look at those odds. That wasn't so hard now, was it?
Not at all.
No, it was not.
But there was only 2 results I could possibly get.
You know what the actual term for the possible results are?
No.
Outcomes. In the case with the cards, you had 2 possible outcomes. You could either pick a black card or a red card. And the outcome of that you're looking for is called the event.
So since we're looking for a black card, that would be the event? That doesn't sound like a very fun event.
No, it's a spectacular event.
Okay, but what if there's more than 2 possible outcomes? Like say we're looking for a black card and a queen. What would you do then?
I'm glad you asked. Let's take a look at that. Now, how many total queens are there?
There's 4.
Right, and how many total black cards are there again?
Again, there's 26.
And we want to find out the probability of getting either a black card or a queen, yeah?
Yeah.
Alright, first let's write the probability of getting a black card. Do you remember what that is?
Of course, it's 1/2.
Now, what's the probability of getting a queen?
Well, there's 4 queens and a total of 52 cards. So that'd be 4 out of 52, which reduces down to 1/13.
Very good! I see you're getting the hang of things.
That still doesn't answer the question. I've got 2 separate probabilities.
That's where your ors and ands come in. That's what we were talking about earlier.
But how do you know what to do? How do you know if you're looking for and or if you're looking for or?
Simple. You're looking for the probability that you'll draw either a black or a queen. That's an or statement. Do you know what you do for an or statement?
No.
For an or statement, you add the 2 probabilities together because it could be either outcome. What do you do for that?
I don't know. I don't have my calculator with me.
No problem. Now, what do you get when you compute that answer?
Hang on. 1526.
See, that wasn't so difficult.
No, but what would you do if you wanted to find out the probability of drawing both a queen and a black?
With or without replacement?
What?
Never mind, that's for another time. So, you want to find the probability of drawing a black card and then it being replaced and then drawing a queen, correct?
Yeah, that.
You would multiply instead.
So, because I want to find the probability of getting both, I would multiply the 2 probabilities together?
Now, type that in and see what you get.
I got 126.
Which is about 3.8426%.
But that doesn't make any sense.
Yeah, wrong you are. What part isn't making sense to you?
Shouldn't the probability be higher? I just don't get it.
To be honest, neither do I. You see, I work the numbers. I don't work how to find the numbers. It's a lot easier to find the answer than to prove it.
Prove them?
I'm just here to teach how things work, not why.
Okay.
Would you like to do another example?
Sure, but I think I got it now.
Let's make sure of that. Oh, okay. Tell me, what's the probability of picking a blue block or a cylinder block?
Well, okay, there's 7 cylinders and 4 triangles, so that makes 11 blocks. The probability of picking a cylinder would be 7/11ths.
Go on.
And 5 of the cylinder blocks are blue, and 3 of the triangles are blue. So that's 8 of the blocks that are blue. So the probability of picking a blue block would be 8/11ths.
That's correct. Now would you multiply them or add them together?
Multiply, it's an OR statement.
Very good. And what do you get?
56/21, 121.
See, this isn't so hard, is it?
No, thanks. Hey, I've got a few other questions about probability.
Well, it's about time I gotta go. Maybe next time you need to get some sleep and I've got things to do and places to be.
Hey, wait though.
Bye now.
Okay, there's 7 cylinders. Multiply, it's an OR statement. Multiply, it's an OR statement.